Yo, what's going on, guys? Hope everybody having a great day today, and welcome back to the channel. In today's video, we're going to talk about what you need to know about tech debt and how to manage it. Okay, so technical debt. All it is just code that functions, it works fine, but when you read it, you don't know what the heck is going on. And usually if you have to ship something a lot faster, if there's like a deadline that you need to adhere to get an MVP out, you're gonna acquire tech debt. You don't care how the code is written, there's no standard, there's no nothing. If the code works, that's all that matters. If the user flow works, that's all that matters, okay? Now, as you continue to mature and get better at coding, you're gonna find issues with some code that was written previously. And if you do find that, that means that you have progressed in coding. That means that you're learning new things. You're understanding a system, okay? And you're gonna look at that tech debt, you'll be like, hey, like, can I refactor this, or is this gonna be downstream effects? Usually, whenever you refactor something, there's gonna be downstream effects, depending on how big it is, and also if it's something that you need to take care of right now. And there's different types of tech debt that I wanted to talk to you guys about. There's deliberate tech debt that you know you're writing crappy code and you just want to get something out the door and you'll refactor it later. Like, you know, like you'll create a comment that says to do, refactor this later or something like that. And you already know that you wrote it, it's not within a standard, you just wrote it just to get something done. And that later down the line, you're gonna refactor it. That's fine. Another type of tech debt is accidental. You accidentally added some tech debt. You accidentally added like a function that's a part of the code that not necessarily is a bad problem now, but it will be later. You added something that's not even a standard, or it's just hard to follow, but now you're gonna reap the consequences of not refactoring it and not cleaning it up. And this happens, like developers will make that mistake, you know, within their code and they don't not even know it. Code that is called bit rot, basically it's just code that no one cares about. No one's using that part of the system, so why should we refactor it, right? If it's fully isolated, you can leave it as is and you don't really need to quantify it as major tech debt, but it's still tech debt nonetheless. And then the last thing is just design, the technical design of things. At one point, it was just, you know what, we're gonna go with this user flow, but as you got better in understanding the system and how things work and how your users are using the app, you realize that what you wrote here is not really good design. It's not really good system flow. So these are the things that you would consider critical in your environment that you need to take care of for a better user experience and also for a peace of mind for yourself when you go to, you know, refactor these things and actually write code that has impact, okay? So those are the types of tech debt that you need to be aware of. And, you know, I have a list here in terms of like how to manage it. At least in my career, the way I manage tech debt and some of the things that you should take into consideration before you even start refactoring code, there might be some issues if you do. The first thing I want to tell you guys about is, you know what, if you notice tech debt, acknowledge it. Acknowledge that it exists, that it's there. Yes, it's an annoyance, but the best thing that you could do at this point is document it. Document that there might be a potential issue if we let this go further as we continue to build our standards of how to write code so that everybody could understand the flow. Because one thing I hate is going to a file that someone wrote and try to follow exactly what's going on with that file. You know, you can add all the comments you want, and I mean, that's helpful, but good code and good flow is, I could just read everything that's on that screen and understand exactly what the flow is. You know, based on the function names, the variable names, how we're passing things into different functions and how everything is being inherited. If that is the case to where you're seeing a bunch of comments and you're like, dang man, like I don't even understand what's going on, just document it. Maybe add it to do in the file itself and be like, hey, we need to talk about this, or this needs to be refactored at some point. Number two is, once you have it documented, talk to your team about a tech debt budget. The way you would quantify a tech debt budget, whether you should spend time on it or not, is understand the impacts of that particular tech debt. Is this going to be a critical piece to the application that needs to get done as we continue to build features and add improvements. If that is the case, you would consider that technical debt that needs to be prioritized. If it's just tech debt that's sitting there and whoever is going to be working on an enhancement for that feature has minimal impact, and whoever's going to be working on that feature next, just make sure to write it in our standard. That's good too. But the percentage that you should go by with technical debt, it should never go above 20%. If your entire application is full of tech debt that's critical and it's over 20%, you gotta fix that. You gotta have all hands on deck, maybe have a week of just going through everything, all the technical debt that was found, brainstorming how to take care of it, and creating and documenting a standard that you guys could adhere to and write the same code. Because granted, not all developers write the same code. We all have our individuality in terms of how code is written, but you have to understand that having a forward standard on what should be the same versus what you could do on your own free will saves a lot of time and headache. And also in terms of reading your code, I can understand exactly what we're doing because the standard is there, the documentation is there. So keeping your tech debt within 10 to 20%, 10% being the best, 20% being okay. If it's over 20%, we got to do something. We got to refactor, we got to clean things up, maybe create an impact assessment in terms of when we refactor this code, what other areas do we need to clean up as well? That will give you a fine line or like a web of different things that you need to clean up so that, you know, you're minimizing the impact and the amount of roadblocks that you would run into if you're creating a new feature around that tech debt. So if you have a team that's dedicated to, you know, only getting better and actually reading the code and understanding what needs to be done and having an open mind to cleaning up that tech debt, that's fine. Any tech debt that's not really critical, you can leave it there for now until it becomes that way, but you have to take care of it right then and there. If not, it's gonna be a major problem. Number 3 is that whenever you're working on something and it's very small, you should refactor often. Refactor early and often as possible. If there's code that's very easy to refactor, you know, maybe you want to combine different callback functions into one because it's only like 2 to 3 lines of code and they're doing essentially the same thing. Like say, for example, if you're doing form validation stuff, you could create an actual function that will validate every single input field in that list. If you're using React, there's React Hook Form, highly recommend. You can actually add validation schemas to it and using Zod resolver as well in terms of, okay, I wanna, for this input field, this needs to be a string and it needs to be a minimum of 1 character in it. You could do a lot of different validation checks, whether it's a string, a number, a Boolean, whether it's a password field, how complex the password field should be. If it doesn't match that, you can refine the validation checks and actually build clean validation steps. So I would recommend that you do that if you don't want to create your own way of validating stuff. And it just makes it easier, just plug and play. If you don't have that luxury of, you know, using a form validator or your project just doesn't require it and is very minimal, maybe you should go about just creating one function, validate all your input fields, make sure on submit that you're doing the validation, or maybe on key press that you're doing it, and just seeing the amount of code that's split out into different functions. Now you combine that into one, is much easier to follow. You don't have to trace each individual function for each individual input, and you could clean things up a lot easier and understand exactly what the flow is. Okay, because readability is key in this case. So if there's something that is very small that you know you could rewrite right now, just take the time to rewrite it. If you don't, it might not be a major headache now, maybe 6 months from now, maybe a year, but there's gonna come a time where immediately it's gonna jump like that and you have to do what you gotta do. Number 4 is automating. Automating is a big thing. So like CI/CD pipelines, right? Whenever you check in a change to a branch into an environment, whether it's QA or production, there's a CI/CD pipeline with that, right? So you could automate unit tests. And to be honest with you, I've never been a fan of unit tests. I never really wrote unit tests until I was pretty much taught why you need unit tests. It just gives you coverage around your entire application. So if something fails, like say, for example, there's UI unit testing, there's integration testing, there's backend testing. If the core functionality of this feature works, you would create a unit test around that, make sure everything works, that you got the right data, that everything is flowing correctly. If it's not, then you could run tests individually in your environment if you want to, but then also in a CI/CD pipeline, you could create a step just for unit tests to run all the tests that are in a test folder. Based on the information that you get back, you're like, okay, well, I messed up on this test, so I need to refactor things and make sure that the test actually pass. Some people, what they do is that if the test is too complex and there's a major problem with it, you just pass it, right? Like you just like, yo, skip this. I mean, you do what you want to do, bro, but I'm just saying, you know, if it's a test that you wrote, maintain it well. Make sure that it's automated to where once you run it in the pipeline, once you check in the commit, the unit test catches the failure in that. Because now you know, oh, okay, so this code is not really correct. So I need to refactor it. Make sure that you're writing good tests and that you're keeping up with it, because I know it's tough whenever you're writing a feature, you just want to be done with it. But adding that test is going to give you coverage, is going to give you accountability of what's going on, and no one's pointing a finger at anybody else. So last thing I want to talk to you guys about is like, when it comes to tech debt, I've been saying this throughout the entire video, but when it comes to tech debt, involve someone that knows the code more than you. Involve your team. If you're working with the team, it's like, hey, I want to bring this up to you guys. I found this poorly written component or this poorly written file that touches other areas of the app. Can we refactor this? And give a use case as to why you should refactor it. If you were to give a great use case on this, you should be good to go. Involving people and just refactoring stuff, because now you're gonna add, if it's something critical and it touches multiple areas and you check that in and it's peer reviewed and all that stuff, no one caught it, screwed, bro. So I want you guys to always, when it comes to something big, ask your team. Do not be afraid of yes or no. They say no, cool. You did what you needed to do. There's something less that you have to worry about. But if you take ownership in doing it, and mind you, if you feel confident in doing it, that's all good, but you have to understand the risk versus reward. If the risk is not that bad, do what you need to do. If the risk is great, bring someone in. Bring management in, bring someone, a senior, someone. Talk about it. Why should we refactor this? What library can we pull in to refactor this? If not, what kind of code should we write to do this so that it doesn't impact other areas? These are the questions that you need to ask. So tech debt, everybody has it, bro. It doesn't matter how big or small it is, it's there. But do you have to take care of every single tech debt that's in your application? No, you don't. But you need to know the risk versus rewards ratio, what's critical, what's medium impact, and just prioritize it. Have it prioritized for your time. Because at the end of the day, you check something in that you refactored and it's breaking other areas, and now it's in production. All hands are on deck at that point. You don't want to be that person. You don't want to be that guy, okay? So that's it, guys. That's the video. That's tech debt in a nutshell. If you have any questions about tech debt, let me know. And if you like this video, please like, share, and subscribe. That's all I ask, man. Just like, share, and subscribe. Let me know how you feel. Let me know how you feel about tech debt. If you take care of it early, or do you wait till it blows up? If you need any help, you can reach out to me at thefullstackbro@gmail.com. All right? Talk soon.